Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. The big ones are going to be like a World Wide Web, the internet. That's going to connect thousands of other networks to work with one another. We have small and medium businesses, SMBs. We have small office, home office. We have medium and large networks. We have a small network. All have unique characteristics, like a large network may have a $2,000 router, where a small home network doesn't have the money to spend that on a $2,000 piece of equipment. So again, each type of network is going to have hardware that's geared more towards their specific environment. Yes, you can have consumer grade equipment in a large business. I've seen that quite often, though it is typically not the best, because consumer grade equipment is not made to handle the traffic or the demand like a large enterprise device would be. Yes, a home router might be $200. A large business router may be $2,000. There's a reason it's 10 times the expense. Other types of common networks that we have to define are going to be called LANs and WANs. Local area versus wide area. A wide area is composed of multiple LANs. The interconnecting of multiple LANs is a WAN. Local being a smaller geographical area, wider being a larger area. So when we talk infrastructure, we're talking how large, what's the size of the area covered, numbers of users, numbers of ports, types of services, and are there any responsibilities? Because we could have a small LAN, but it may consist of a much larger responsibility, and so we may classify it something slightly different. LAN and WAN are just two of the more common types of connections. We also have a PAN, a personal area network. Bluetooth and your mobile phone in your car, those are all part of a PAN. So again, don't get hung up with LANs and WANs. Those are just the more common of them. A LAN will interconnect in devices in a small area. A WAN will interconnect multiple LANs over a larger area. Administrated by a single organization for a LAN, that's pretty typical. A WAN may be managed by multiple individuals. LANs might provide a high-speed connection internally, where a WAN may also provide high speed, but realistically will offer much slower speeds because of how many devices they are connecting. A common WAN is the internet, because the internet is a worldwide collection of interconnected LANs and WANs. Again, WANs are connected using WANs, and WANs could use, again, any type of major media, copper, fiber, or wireless. The internet is not owned by an individual, it is more of a collaboration. So there are organizations that help structure and oversee the internet, but they do not own it, like EITF, ICANN, IBAB, IEEE, like all of those are major players in helping define standards that we use. Now again, they're not saying that we have to use them, it's just those are what we typically would use. Alright, moving on. We have an intranet, we have an extranet, and we have an intranet. The internet, like the world, the internet that we're all familiar with, that consists of all networks. We have extranets. Those are going to be something outside of your organization or outside of your house. They may be suppliers, customers, other collaborators, things of that nature. If we're talking a network inside only your organization, that would be an intranet. So again, we can have multiple types of networks just depending on our requirements. So what type of internet connections are out there? Internet connections are, again, typically the network connection between a house or business and a provider that provides access to the internet. Those providers are typically called service providers or internet service providers. The more common internet providers would provide things like broadband or a digital subscriber line, DSL, or a wireless LAN, or more importantly, lately, like a 5G mobile wireless service. Those are also options. So internet access could also be having devices access the internet, like phones, like printers, like, don't ask why you'd have a network printer that's on the internet. I've had a few clients do that, but that's really weird. But I mean, you can have in devices that are accessible on the internet for whatever reason. Typically because you have a need for that connectivity, so you make it happen. So let's talk internet connections based off of requirements. If you have a home and small office, you're looking at things like cable or DSL. Maybe if you're in a rural area, dial-up. Maybe cellular, maybe satellite. However, more realistically, you're looking at cable or DSL. If you're in a rural area, maybe satellite. It just kind of depends on your circumstance. If we're talking a business internet, we want some type of dedicated internet connectivity that we know is always going to be available. So we have dedicated lease lines like a T1 or a T3. We have Ethernet-based LANs, that's Metro Ethernet. You end up paying way more money for these services, but these are typically guaranteed up, and there's an SLA, there's an agreement that says if this goes down, the ISP is paying you money for downtime. So Metro Ethernet, Ethernet WAN might be also a better version DSL or a better version of broadband. We also have things like fiber to home, which I know fibers are not on this, but fiber to home is, or fiber to business, is a growing popular connectivity type. You can also have satellite in rural areas, or you could have satellite in more mobile structures, but it kind of just depends on what you need it for. Network convergence is a very important concept. We used to have one network for each type of major data. One for voice, one for broadcast TV, one for data, for computer, for email, things like that. Where now we have what's called a converged network. We have one underlying technology, typically called Ethernet, and off of that we can have everything connect. And that means they all follow the same rule and agreements. So we can now share our network. This means less cabling, less infrastructure, and less overall costs. We have a video going over Packet Tracer that I will be posting later. You should become familiar with Packet Tracer as all the labs will be done in Packet Tracer. I will show you how to navigate and how to use Packet Tracer in a general flow. You do have one lab, which is network representation. Go ahead and complete that. I'll be posting videos of labs later, and if you look in the description, I will be posting a link to those lab videos as well. Moving on is our reliable network. How do we know if a network is reliable? The common characteristics when we are designing a network are things like reliability, and that will encompass scalability, security, quality of service, and fault tolerance. A nice happy balance between all of these 4 major characteristics. So these are the common characteristics. So fault tolerance is typically when there are multiple pathways, so if one connection goes down, things still can work. Reliability means being able to provide redundant connections so that communication can always occur. Here is a perfect example. We have 2 connections going out to the internet. If this connection goes down, we reroute to a backup, and vice versa. This is not possible with certain circuit switch technologies, which establish a dedicated circuit, because if the circuit goes down, they're dedicated. That is why we typically look for more of a packet switching technology that allows us to quickly change path based off of the packets. A packet is just a small piece of data traversing the network, and we're going to get into those a lot deeper in a later chapter. Scalability means it can grow, it can scale. If we need to add 50 users tomorrow, we can. If we need to add 1,000 users tomorrow, we can. So again, scalability is how easy it can expand and quickly grow without impacting performance or services or existing users. Quality of service is basically as data transmits through the network or traverses the network, it uses resources. We have things like a phone that uses a real-time communication. We have a computer that uses not so much real-time data communication. A website, for example. So we can classify what traffic takes priority. If it's real-time traffic, voice or video, it goes first, like a live video stream. That way it is always in sync. Where a website may have to take an extra half a second to load, not that big of a deal. A website would not have that priority or that live data component. Now, if you're talking like a Zoom call or a WebEx call, video conference call, that's slightly different. But we'll look at what type of traffic is going over the network. If it's real-time required or real-time preferred, then it gets priority. If not, then we treat it as not priority. Part of the reliability of the network is also about how secure the devices are. There are 3 goals in network security. Confidentiality, basically meaning only the intended recipient can read the data, read what's being sent. Integrity, that's the assurance of whatever I sent was not modified or reviewed in transit. And lastly is availability. And that's the assurance of timely and reliable access to the data for the users that are authorized. Again, timely and reliable access. Within network infrastructure security, we talk about physical security. Can someone walk off with the device? Can someone accidentally plug into the device? Things of that nature. If we're in a bank lobby, can I see a port? Can I plug into that port? If I can plug into that port and I get network connectivity, that may not be a physically secured port. And that is it for this lecture. If you have any questions or concerns, please reach out. Thank you.